Right, so we can add a curve onto it. Now all this actually refers to is what that point of deforming will happen, where it will happen. So I'm just going to roughly put it there. Now if I want, I can add 20, 30, 40, 50 curves if I wanted. In this case, because I just want to show you this, I'm just going to stay with one. Then, once I'm happy with that, rather than left clicking, I'm going to right click once. Now what I can do is just go OK. Oh, hang on. Right click on there. Oh, it's not allowing me, so I'm just going to go add points. So I'm going to add my points. Now you see there, on these add points, it says where do you want to pull it from. So this would be the equivalent of your finger and thumb on that material, on the piece of cloth that's on the glass. So if I left click on there, now what you see is these arrows emerging and a plane. Now the plane's based on the curve that I've added. These arrows are the normal twos based on the edge that it's coming from. Now, as long as my cursor has a red, an orange curve point on it, I could add more if I want. So I could go one there and one there. And then if I right click, this better work. My God, that didn't work either. Adding points. Let's have a look. So I've added my points. Right, thank goodness. You see there where it's come back. Right, I'm going to come off adding points. And now if I click onto the curve, what you'll see is that I can actually manipulate these. So if I move it up, and then move this up, and then this up. All I'm doing here is just manipulating. 2 seconds, had a question come through. Have I had a question? No, I've not. Oh, yes I do. So, again, adding points. Click on add points. Add curves. Yeah, escape seems to work better. It does. I mean, normally you can right click and it should be able to jump it out, but that didn't work well for me. So I've done that manipulation. If I click OK, now what I've got is a profile where it's manipulated, it's pulled, it's bent, it's moved like I wanted it to be moved, and then we've got, now you can't really see that very well, so is that any better? No, that's probably even worse. But you can see there that it's created a profile based on my my hand manipulation of where it was moving. And that is the simplest as that. What it must have is a way of being able to map that closed area. Without that closed area, it does struggle to be able to complete. So this is the reason I was showing you this. Is this is one of the reasons? Well, this is one of the big tricks. If we get to something that's like this. So if I come to my top plane, I'm going to go back to sketch and sketch and bring in a circle and just drag my circle out. I'm going to go dimension, and on my dimension I'm going to make that 30 millimeters. Two seconds, just had a question. The last question that I had personally, can you refine your question a little bit? It's not clear what you mean. Right. So now what I've got is if I go here, what I'm going to do is go surface, and I'm going to go surface extrude. Now, based on the notes, I'll do it again, and I'll go 130 and click OK. And that now is all the geometry I need to be able to create the grip. If you're getting that complaint where the green tick comes up and it says that it's not been properly modified, we're going to go through another modification now on here. I'll try and go nice and steady with it, just because getting used to the blasted thing moving like you want it to can be a real pain in the backside. So I'll try and go as nice and steady with it. It's probably the easiest way just to practice. Ah, right, so the last question is a refinement on that. Will it become more of a hollow shape? Yes, it will. That one that I was doing before with the triangular shape, it will be cone shaped, but it's based on a spline that you're manipulating. So no matter how many points, if you just put 1 point on, it will be cone-ish. So you'd end up with almost a filleted top of that cone. But yes, that's exactly it. Right, now, as I was saying a minute ago, what we're going to be able to do is make sure that we can split. Now, this is basically because on here, if you look, I've only got 2 points that close this geometry. This type of geometry is a pain in the backside when it comes to freeforming 2 particular points. Now, don't forget, on a grip, we've got a back and a front to it. So what we're going to essentially do is we're going to manipulate one side, then manipulate the other. As a tool, yeah, again, it's a pain in the backside. So I'm going to right click on there, I'm going to sketch and sketch. From there, I'm going to go my convert entities. Now you've silhouette entities, you've got your standard convert entities, or you've intersection curve entities. Now I'm going to go intersection curve because convert entities on a round edge does not work because it's a round edge. But if I select onto there, what it actually does is says, right, across any curved edges, pick up the geometry and project it. So if I click OK on that, what I'll get now, if I click OK, let me just bring that down, what I get now is 2 key vertical lines which lead on that edge. So what I'll do, Control and 8, bring that normal to view, and I'll just now close the geometry top and bottom. What this now leads to is a rectangle which gives me that reference geometry based on what I've actually put on. If I come back out and I'm going to go Features, Curves, Split Line, Projection from this sketch onto this geometry. And then all I do is click OK. Now what this actually does now is turns the back and the front into 2 curved rectangles into the same geometric representation of what we've just been doing. So here and here. Now it gives us them all important edges for us to be able to freeform. So obviously we have our top edge, our bottom edge, and our key intersecting line edges that we've just split. So we've now got a good reference to be able to model one side, then model the other side. So what I'll do is come back, spin it out a little bit, and I'm going to go Surfaces, Freeform, and I'm going to split it. And as you can imagine, it's giving me the map across the whole thing. I'm only using one curve on this, so what I'm going to do is just bring it back to show you what I'm actually doing. That's a good comment, but we are on what, week 4? So the fact that you're asking me that is interesting. I've been recording this for 4 weeks. Does that mean that you've not interacted with any of the nodes? But yes, I am already doing that. So we're splitting it down. We're splitting it down, and all I'm doing is I'm going to put a curve, basically, looking from this right face. I'm going to put a curve almost perpendicular to it. Let me just see who that is. I'm almost going to put a curve which is perpendicular to it, and I'm putting on 8 points. I'm going to put 8 points on there, and then from there I'm going to manipulate to get to that. Now it's going to be a challenge for me to actually recreate that again, but this is called, somebody told me that this is called the dipping hawk idea, of where you end up with the almost like the eagle head type, and then it curves down to actually create like the chest of the hawk. I didn't know that, but it was a student who told me that. Oops, that's me shaking my mouse too much. Right, so what I've got is, I'm in that state, so what I'm going to do is come to my viewer. I'll go to right plane. Oh, is it not right plane? I always thought it was right plane I'd taken. Oh, there you go. That's one I'd taken. So anyway, I'm going to go to add curve. Now with my curve added, you should be able to see that you can only interface where that split line is. So what I'll do is just zoom it in a little bit. I'm going to bring that right to the perpendicular point that I can no longer see, so like there. And then if I spin it up, bring it round, I'll see my curve is could be a bit closer, but I'm not too fussed. Or what I could do, I've just realised what I could do. If I go to add a curve, bring it up, and I'm just going to try and line it up with, add a curve, come on you swine. I'm going to try and add it up with my markers. You see where my markers are? At the front and the back. Line it up with them. They'll roughly sit central. You can put points on it, but with Freeform I have never spent a lot of time doing that, just because this is more of an aesthetic tool, let's call it. So I've gone escape, and now I'm at that point. Now if you look, I can now select the curve, but I want to add some points. Now with adding points, this for me is the bit where if I want to match against the notes that I've given you, this is the bit for me where I do try to match against what I'm looking at. So again, I'm just going to come back and go to my front plane. There we go, we're going front plane. And let's have a look. So 6 are heavily grouped to the front. So based on the notes, 2 seconds, I had another question come through. Have I had another question come through? No. Apologies, just like to keep checking for questions. So I've got 6 heavily grouped to the front, and I have 2 at the back end. So what I'll do is I'm just going to go 1, 2, 3, 4, 5, 6. And then to the back end of the geometry, I'm just going to go, let's have a look. So if we go just above, we'll go 1. And I go mid to the point here. This is what creates that dip. And then again, I'll just escape out of that. And now we're ready for manipulation. Millions of things coming through. I have to keep checking because I don't want to miss your questions. I said ignore, but I don't want to miss your questions, so I just want to keep checking. I've just had another question. Can you please record the lecture just in case we struggle and we can come back to it? I've been literally recording these sessions now for 4 weeks. They're always uploaded every week, timely, and it's a bit concerning you're asking that question, because that tells me that you've never even looked on these notes I'd strongly recommend that you look on Blackboard and check them notes, and then come back to me if there's any further problems that you've got. But asking me a question where I've been explaining to you again and again that it's there is a little bit concerning, I won't lie. So please can I ask you to be a bit more accurate and a bit more acute in checking for these notes, because these are only there to support you, not for me. And right, so I know that sounds a bit harsh, but it is important to keep these things in mind, that I will assess you on this. So yeah, right. Apologies everyone. Let me just get back to it. So all I'm going to do is drag this point out. Now I know, when you first look at it you go, oh my god, that is, good god, that is awful. That is just terrible. Now what you want to do is you want to try to bring that in to give yourself a nice curve. And if I click onto my line, where is my pointer mark gone? There it is. And I'm going to bring that in, and it just allows you then, because then what you start to get, when you get these sharp edges like this, it does start to really look a little bit more slick. And I'm going to tighten that up a little bit. And then what I'm going to do is bring that round. Oh, that's not working out well at all. Oh, now this is where the system now is going, your geometry is so crazy, I could never generate this. I don't know what you're trying to do, but make sure that you fix it. So if I clicked OK, it will bring back error. It would say, I cannot work, I'm not sure what to do. So again, what I'm going to do is bring that out. And this ripple here I'm not too keen on. Won't lie, not too keen on that. Now if I want to see how it's bending, now often sticking this out can be quite useful, because you can look and go, this edge, based on these bends here and here, this edge looks a bit too aggressive. So what I can essentially do is take that back off, because it feels trippy. If I bring that back just a tad, bring that up just a little bit like that, and then bring that down a little bit. Because essentially what I'm looking for is that almost fighter pilot button type effect. So what I'll do is just bring that up. I'm going to tip this out. Not convinced with that one. It's not one of my finer works. Right, let me have a look. Yeah, you can, Harry. What you need to do is go back in, and then you need to start removing the points back out. Sometimes it's easier just to click cancel and start the fresh process again. Pain in the backside, I know, but what this is really about is just getting used to pulling these points into position and then getting your dips to move like you want them to. Yeah. So this is what gives me that all-important arc between there. You can see there I've probably grouped a little bit too much together there. So if I bring these down just a tad and bring that down just a little bit. Yeah, it's not bad. Could be better in my eyes. I think it could be better. However, if I was marking that, it's proof of concept. How could I actually be anything else but okay, fair enough. So movable. Now I've changed that to movable. Now the reason is with that, what I can do is bring this out and then down a little bit. And what that'll do is it'll drag that sharp edge. You know the sharp edge where you're looking, you go, yeah. So if I bring this back across, see this sharp edge here? This sharp edge, yeah, it's good. It's a good shout. Just to answer last question, it's a good shout. I've done the same thing many times. I just think, oh, I can't be bothered. So what I'll do is just start the actual full thing again for that exact reason. Um, yeah, I've actually had the exact same question on a personal message. So can I delete points if I've got too many on there? That's literally what we were just discussing on the main feed. You can do, but once you start deleting the points, you've got to redefine them, put them on again. And I swear to God, it's often easier just clicking cancel and then redefining that line again. I mean, it is with something like this, because you've got to remember, on something like this, we've got a single piece of geometry here, well, a single point of geometry manipulation. If you had something like 30 or 40 lines on there, then yeah, agreed, you want to start removing points that way. But otherwise, using it for something like this is quite nice, really. Right. So, if I click OK, I've now got my first piece here. This is my first piece of geometry I've done for my handle. And then what I'll do is put on, now I like to try and make something that's almost parallel to, it's almost collinear as such, to the edging that's coming here. I don't like to go too over the top, because you've got to remember what you're trying to do is get that grip. So your hand will naturally form, and what you're looking to try and do is almost sponge against the base of your hand, which anybody who doesn't know, the base of your hand is the most important part of your anatomy. So you break, you damage that, or injure that, you can lose entire functionality of your hand because of this small piece of muscle that's in between it. The other question that I've just had, I take it that has been achieved in Inventor, and yes, that the image that you've sent me, yes, you will find that. One of the group has just noted that this process, the entire manipulation process in Inventor, is achieved a million times quicker. Yes. As we know, Autodesk are phenomenal with being able to control manipulated surfaces. They are the daddies of NURBS. So when it comes to this is where desaltering very, very salty water for them. So when they first get to that manipulation tool, you kind of go, it's not what I was after. However, on Inventor, it can be very, very good. Very good. So we have found so far some of the tools in Inventor do come across a lot of inferior in comparison to SolidWorks. However, this is something where, yeah, this is where they shine as a toolbox. Right, so I'm just going to spin that back round, and I'm going to go freeform, and again snap it onto that back, mapping that out, and I'm going to do the same thing, just add a curve. Going to add it to where them key points are, which is roughly where them contrast points. Add that onto there, and then, like we were saying before, I'm going to click escape. Now you see where I've got contacts. I like to set these to movable, and that's what gives me the arrow, not there. So if I go there and go movable. Now when I start to add points, I'll get the arrows that allow me to drag the way that surface is flowing in between it. Gives me more control. Some people don't like it. They like to have almost like a very normal two relationship between the sketch and that key, that all important face that's translating. But I think having a movable aspect allows you to almost get a tangential relationship between the curve that you're doing and the transitional move. That is something you'd need to practice with. Get used to just manipulating, moving around. I've added my curve anyway, so I'm just going to add my points. Now, if you've not seen it on here, I used the all-important 2. I went roughly around mid, so it was roughly, well, it's just beneath mid, so it's more like, it's actually more like there. Now the reason I'd done that is I knew that I was looking for a lower curve as it came down. This was going to be quite a wide body, and then the lower aspect was going to be, well, the lowering of that curve was going to be around here. again. And I've clicked escape. Now that you see there, I don't know if you saw it then. Let me just see if I can get back on here. See where you've got the symbol on the screen of hit the right mouse button? That's what it's trying to tell you. You can hit the right mouse button. For some reason it wasn't working for me. Just my luck. So I'm going to left click on there, and now I'm going to do a little bit of manipulating. Bring that profile out. Again, I don't want to go too crazy. So one thing I've realised, if you notice here, I've actually brought this profile out too much. I could do with that inner curve where it comes in and doesn't have, because I mean this handle looks like it's got a beer belly. I'm going to come back because it's so irritating right now, I won't lie. So what I'm going to do is just come back, and I want to I just want to change that because I don't like it. So come onto there, and these, I mean these are good, but bloody hell did they get in the way. So what I want to do is bring this down. Let's see if we can pop you in a little. Whoa! I mean there's. So can I just bring it out? A little bit there. Bear with me. Bear with me. Oh, I think I've wrecked that one. It's a little bit better. Oh, this process can become quite obsessive. Very obsessive, in fact. So I'm going to, again, add my curve because I just wanted that. I want it to give me that, that hand grip relationship about it. So I'm on there, and is it going to let me? I'm going to try it now. Right click. Oh, it worked! Amazing, it worked. Can you believe it? Well, I can't. So I'm going to go just beneath that point. So I'm going to bring it just beneath, and then I'm going to add one roughly around down on my third division, so around there. And then all I'm going to do now is it going to work? I swear to God, it wasn't. I mean, you all saw it. It wasn't working. So I'm going to just bring that up, and I do this just because it gives me an insight as to what the relationship is across here. So if I bring that out, if I go like that, you kind of go, yeah, that's definitely wrong. But if I bring that round something like that, you can see I'm trying to map against this flow here, and I've got this curve in here. I don't really like that, so I'm just going to bring that out a little bit. Bring that up a little bit. You see what I'm getting is that overall grip where the hand's going to be cushioned around it, and then the fingers are going to be manipulated to a key point. Somebody told me, I don't know how true this is, but somebody told me that when you have handle in this type of design, you naturally know that you want to be able to put your hand around there, and your thumb will almost want to tickle around this area, which I didn't know that. I don't know how true that is, that's all. So I've manipulated, and I'm going to confirm it. Now what I've got is the overall geometry of my handle, which is good. Right, so and what I really want to do now is I want to be able to keep in mind that I might want to simulate in form. So I'm actually going to do everything in surface, everything, and only convert to solid at the end. So I've still got that freedom of saying, I'm going to change this, going to change that. In fact, it's crap. Let's change this, let's change that. So I'll go planar surface. I'm going to go top, cap that off, flip it over, bottom, and cap that off as well. That then caps both sides. And all I'm going to do now is I'm going to now put in the internal stem. Yes, you can freeform a solid, however not as well. When you freeform a solid, what it will do is you'll be restricted in key areas for direction. Now when I'm moving around then, it were allowing me to move in all different directions. Now don't forget, the biggest problem with this is if you have geometries that almost overlap each other, what you end up with is zero behaviours. This freeform in surface has that little bit more flexibility to it. With solids, it can lead to error and it can lead to it breaking down completely. If you're operating in a surface, it does have more freedom, total more freedom. So I think that's the best answer for that. But also, if you freeform a solid, you've then restricted your ability to be able to simulate everything that you want, because you're instantly restricted straight away. You cannot move away from being in volumetric behavior. Once you're on that volume, you've pretty much said what it will be. And if you're looking to simulate forms or the behaviors of forms, it's very problematic with a solid geometry, because the two methodologies collide and you don't get a true representation. Okay, I think that's the best answer. I hope that helps as an answer, but yeah, I think that's the best answer. I only actually say these answers though with a real voice of experience, because it's something I've done many times before when I was trying to figure out how it's done, and then I realised what I was doing. This is me as a student. So I'm going to click on my bottom flat, my planar face, click on sketch and sketch. I'm going to quickly put on a geometry, I'm in a radii of 18 millimeters. So come onto here, I'm going to go 18 millimeters. 18 millimeters, by the way, is actually the diameter size of a lot of the hiking sticks, which again at the time when I was first introduced to this, I didn't know that. That's the rough average, that's the average. No, that is the size. So what I'll do is go surface, and I'm going to go extrude. Going to go, what were we on? We're on 110. Come in, go 110. And then click OK. Right, so I'm going to trim it. Now again, you'd often think, well, I can't seem to select that. How do I get that? So what I'll do is go trim. I'm going to go standard trim with this face, and it's going to say things to keep. Is it going to select it? Look at that. Oh, it won't even select it. Then what I'm going to have to do is move to the next idea, which is using cross section. So let's try that. So then I'll go surface trim. I'll use that as a standard trimming tool, and things to remove. Then click OK. And the one thing that it's now missing, because what I want to do is I want to be able to close this surface. The one thing that it's missing is a planar at the top, because if I close it off, at the moment it's still empty at the top. So I'll come back on, click OK, and I'm just going to put a planar surface on the top, and then OK. Close that off. And now, I can't remember if I've filleted this before or after. Oh, it's before. So what I'm going to do is go fillet. And I did this last week with the lofting. So we did a face fillet last week, if you remember. Now, as long as I've got enough space on this geometry up here, this should work. I've had a couple of times where I've actually swallowed this space up too much and there's not enough for it to fillet. So I'm going to click on my upper face. Now my pull direction should be going down, because I'm actually wanting to bend the face inwards. And then what I'm going to do is bring in this face and this face. Definitely not 10 millimeters, just saying. Now the notes, I've actually asked you to put on a 1 millimeter. So you click OK, it should give you a nice fillet on the top. Okay, so if you've not done already, we can now close all this off with a big old knit. So I'm going to left click, drag over the entire thing, make sure everything is selected, click merge entities, so this brings together any of the blue lines, and then click create solid. This now fills the empty geometry as a solid, and then click OK. So then just to check, again, I've now got that freedom again. I can go back and go, right, I can change that, I can do anything I want with that, I can even extract this. Now, one key thing about this, you've not really seen this yet. So if I just minimize that, I've just pulled up my progression bar here. Now if I right click on there, and let's have a look. If I right click, now let's say this is a surface body that, let's say this is a solid geometry and I need some key elements from it, so I just need that profile. What I can do, let me bring that back, I might bring that back because it might be easier this way. What I can do is, if I go to surfaces, if I go to offset surface, I select here. If I select that to be in 0, and then if I go to my bodies, right click here. Now I can do whatever really. Now this is my surface and that is my solid. So if I delete that body, I'm just showing you what I've now got is a surface geometry to use. Now this is a way of extracting important geometry. If you're doing a CFD model and you're wanting to extract the internal volume of a combustion area, what you can essentially do is recreate the exact same thing I just did and actually create that volume and put that straight into ANSYS, and then start to look at the combustion process and look at the combustion volume area. If you're doing any type of shin guards for footballers, anything like that, if you have a scanned profile and you want to make sure that it's ergonomically sound, you can take a reference of their body, if you will, and actually use that to model around it. This is not plausible as a solid. You cannot, you are extremely limited when you move to that particular point. Being able to have a lot of surface experience allows you to be really free in which way that you're going to go with your designs. If you do, this is quite common, but if you do want to, let me just double check if I had a question come through. No. If you do want to change the appearance of the material, now this is relatively new. I'm just going to change my material to pine and it should just change it. So I've gone onto there, gone to wood, go to pine, click apply, and I just made it a wood before. So what I'll do is just remove any lines, and that is your handle. What I would recommend is that you practice. Have a go at using freeform. Choose something else to freeform around. This was just a stick. Let's say you were doing grips for a steering wheel, or a lot of the F1 wheels, they have a lot of grips. If you're doing any grips for mountain bikes, motorbikes, if you're doing a particular grip for equipment, things like that, have a practice at actually manipulating that. Get used to being able to do that. It is useful to know, and it is extremely useful to get used to doing. Yeah, well, that's a very good one. The eco car wheel. So the wheels themselves, any bodywork that goes around the wheels. Doing this, to actually do it, I don't know, I mean, I'd be surprised if it took you 20 minutes to actually get some overall geometry. And granted, it needs to be manipulated, so it probably wouldn't be finished in 20 minutes. That I totally get. But moving around and getting used to doing that, you know, it's dead straightforward. So, I'm just checking to make sure I've not missed any questions. I've not missed any questions. Great. As I said, I'm trying to keep some of these notes shorter to allow you to practice, to be able to take a look at different things, and for me to answer any, for me to help with any key problems that you're having. Just because we are getting that one step closer, and if you are on motorsports, aerospace, CAE, or mechanical, CAE and mechanical, you're going to be on the same assignment. Motorsports and aerospace, you are going to be on different assignments. There is going to be changes to these assignments, so please don't think that there's anything similar to last year. Well, there's similarities, but they're not identical. Far from identical. Motorsports, I will be, just to let you know, I will be changing your vehicle in opposed to last year. So the approach will be the same, but your vehicle will be different. So this year it will not be the Formula Student car. It's going to be something else. Aerospace, you will have similar approach, but it's going to be different. And CAE, yep, mechanical, yep, you are going to be tasked with something very similar to aerospace and motorsports, but it's going to be human. Right, so moving on swiftly. If you've not done already, save that. I'll save this because what I like to do is produce this, upload it, and then you guys can take a look as a reminder. At least then you've got everything that I was doing. So I'll just call this freeform handle. And then I have another example that I want to show you. Now this one is dead easy, but this one is one that is really useful on the most pointless of things, but it is incredibly useful. And the best way I could describe it is a phone cable. 2 seconds. I'm just going to call up these notes. Now, some of you will go, yeah, well I know how to do that. Surface helixing. Now I know a lot of you will go, well I'll just create a helix. But I'm not talking about a linear helix. I'm talking about a helix around curves. I'm talking about a helix as it moves in many particular ways, and how it can actually change itself, and making sure. So the best example of a helix which is bent around all randomized areas of curves is a phone cable. So this is the particular set of notes that I have. Now the one thing I should tell you is you can do this much quicker and much easier. But I'm not going to show you that just yet. Not yet at all. What I'm going to do, first things first, open it up. Now this is about creating paths for our profiles to map around. Now don't be fooled by this. This is one thing where Dassault have never been happy. They've never been happy about geometry moving in 3 components. If a geometry moves in 3 components, if a 2D sketch is moving in 3 components, you kind of sit there and go, that's total madness, because it's a 2D sketch. How can it move in a 3rd component? Now the best way I heard this described from an Autodesk guy was, imagine that you've got a piece of paper and then you attach it to a bar and then it rolls around that paper. That's how Autodesk do it. Now Dassault, what they say is we want to make sure that everything's sitting in place, so we've got to pierce through each component to make sure it has that freedom to move like we want it to. So what I'm going to do is I'll go through this, and again it doesn't take long. However, it opens up a lot of improvement, and then I'm going to let you have a go at trying to figure out how to make this better. So what I'll do is go sketch and sketch. I'm going to put on a circle. And just to stick with the notes, again I like to stick with it just because it gives you perspective of what it is that I'm doing. If I come back and I've got now one sketch, so what I'm going to do is put another sketch on the top. Do not put these two together. The most common thing that I find is many people go, it's alright, it's going to stick it together, be alright. Now look at the geometry that I've put on. What's key about that geometry? There is one relation on it, nothing more. So don't bend that neither. So I'm going to put that there. What I'm going to do is press Control, fingers on Control, select the point, select the target, and pierce. Then from there I'm just going to pull this in and make it vertical. I've not got a vertical constraint on there. There is not a vertical constraint on there. Then what I'm going to do is come over here and I'm going to create a profile that I'm going to actually sweep with this. So first things first, I'm going to sweep my profile, my path. Then it comes back and says, yeah, that's what I can do. So if I go options, twist along the path, I'll go with a twist value. So with my twist value, I'm going to go number of revolutions. I'll probably just go 15. Is 15 going to do? So 15 is not so bad. So with 15, now I've got this almost like a ring of quavers type look. Now, if I want to create something to follow that path, what I'm going to do is go to Sketch and Sketch. So I'm going to put on a circle. Oh, what circle size did I put on this? Oh, I actually didn't put one on. Incredibly naughty. Press Control, select the point, select the path, and pierce it. And then all I'll do from there is surface swept along there. And that gives me my it's like a, I don't know what you call it. I'm sure somebody's going to tell me what it's called. In the answer to, is there a pierce constraint in Inventor? This is what's really frustrating. Autodesk don't need it because they are masters of moving around curves. They are incredibly good at moving around curves. So in Inventor, as long as it's constrained to the path, it will always try and move around that key defined geometry. I was asking that very same question not a couple of days ago, and that's the answer that I got. And if you look at some of their algorithms that they use for relation of sketches, mind blowing. But the trouble is they put so much on there that sometimes it hinders you. So this is where Dassault stuff comes in and stands on its own. It's such an interesting contrast between the two. Right. Now, bad about doing this. I've hidden a surface. Hiding surfaces and not me dealing with that is incredibly bad technique. Hiding surfaces is a very frowned upon technique. So technically, that geometry is what I'm after. The problem is I've got a hidden surface. My challenge to you now is figure out a way of fixing it. I will give you 5 minutes to fix it, starting from now. No! That's the point. If I hide that, if I export this and put this into, let's say, Cura, let's say I put this into ANSYS, ANSYS instantly sees this. Ooh. No. It's a good point. Don't get me wrong. It's a really good point, and that would be my first go-to. In fact, shall we have? Let's have a go. You're obsessed with hiding. No. So what I'll do is try trimming it. If I go mutual, I'm just going to try this just because I won't lie. It's not one that I've actually tried before. So let's try removing surfaces. Is that going to work? That did work. Look at that. Nice. Yeah, like that. But there's a quicker way of doing it. That's a good answer though. That's a very good answer. But there is a quicker way of doing it. This is just a nice... I always run this particular example just because it's a nice way of getting people thinking, well, how do you do it quicker? We've done it. We've literally just done it. And when you see it, there is a massive anticlimax with this, I won't lie. Come away and go, oh, that's a bit crap. Okay, so the anticipation is killing me. I'm going to show you. I just want to point out the answer of trimming, like the trimming one by the way, splitting and hiding. No, we're not splitting and hiding. Trimming would be a good answer to it. You may come across that way, you'd have to do it again. Totally get you with that. However, what I wanted to do is do away with having this all in together completely. Now we did it from the start. Now I always do it the long-winded way and the mess you around way, because I'm just trying to get you to think about what it is that you're doing. So let's go back to the original. I went to Sketch and sticking with the notes, I think that was 80 mil. Yeah, so we're 80 mil. So I'll go 80 mil with that. So I'm going to set that to 80 mil. Boom, we're now in a fresh state position. We know that is the path. So, I'll tell you, I was praising about naming and I've not been naming all morning. How bad is that? I swear to God, I don't know how to fasten my own shoelaces. Right, so what I'm going to do is go on to Sketch. Remember we did a line. Why not just do a circle? As I said, a big anticlimax. But why not just do a circle? So the issue that we get with this now is it can have a meltdown if these geometries overlap each other. So what I do is come back out. Just going to rename that. I'll just rename that as profile. So as ever, you get your profile and your path. And if I go to surface and sweep, I should say swept surface to be more accurate. So I choose that's my profile, and that is my path. Now as ever, the system comes back and says, these two aren't connected, what are you talking about? However, this is one thing that it doesn't clearly explain. If I go to twist along path, let's go path, sorry. Yeah. So I'm going to twist the specific values. I'm going to go there, revolutions, and then I'm simply going to go 15. What it now actually does is it creates a profile that can move along that path. It's a bit stretched, I can make that a bit bigger, won't lie. But now what I've got is I've got the whole profile in one surface. This as a tool is great, it's really good. Because now what I can do is get really cocky, and I mean really cocky. So if I come back and I'm just going to delete that out. So going back to my path again, I'm going to edit this path. And for this I'm just going to turn that into construction. I'll leave that on there. At least then there's a reference for me. So if I go Control and A, and what I'll do now is rather than having a linearized path, I'm going to go right up here, over to there. These points, by the way, I'm just making note, there's no specifics. And click OK. And then close. Now I come back to the profile. I keep seeing flashing coming up, I have to keep checking for questions, I don't see any. Now come back to the profile, bring it up, bring it down, and now if I do swept to profile, path, now it just has a bit of a meltdown. It kind of goes, what the hell am I doing? So if I go options, again, I'm just going to go for my normal. I'm going to twist along the profile, along the. Now this is where it's going to get tricky. I'll show you what I mean. If I come on here and go 25, is it going to do it? Oh no, that did it pretty well. What I've actually got is a stretched spring. I've got a cable. I've got a phone cable. I've got a spring that moves around a particular path. I've got multiple ways of being able to describe this thing moving, and the beauty is it will stretch relative to how the curve appears. So I'm now in a state where I can do all sorts with it. If I zoom in, it's just a normal path between it, but now I've got such freedom of being able to helix around a curve, a spline, a path. And that is one beautiful tool on it. So that is a way of helixing, and again, the reason I put it on here as finishing up like that. I've actually already shown that there, but the reason I put this on here with there is because I want you to think about making it better, making it quicker, and making a better way of being able to do it. If on your assignment, if you can minimize the sketches needed, if you can minimize the amount of stuff that's being interfaced, you're actually in a very strong position of being able to do more and more things with it. Yeah, a lot of you here, as I've just pointed out, a lot of you here won't recognise this as being a landline cable, but this is very much a landline cable. This reminds me of when I was a kid, to be honest. You have these big, awful, like weapon type phones where they clung together. But yeah, this is very much the old landline cable, and even some of the more newer phones don't have this awful type of effect. But this can be useful on many different aspects. When it comes to motorsports, you are probably going to need to use this a couple of times. Aero guys, you are going to need to use this for a few things. And with CA and mechanical, yes, you're going to need to use this as well. So there's going to be many tools that drops out of this. There's going to be many uses that's going to be for this. But keep this in mind. Right, so as far as notes go this week, that's all I wanted to actually do. These keynotes here are just about getting used to small tools that you wouldn't be aware of. What we've done today is look at Freeform. Freeform as a tool. We did a basic example, and we produced a part which is very common. What I was now going to do is I'm going to put myself on mute and I'm going to hide my camera. I want to use the rest of the time now to answer any concerns that you got, or to help you if I need to step back and show you some other things that you've not covered, or you struggled on particular extra sets of notes. I want to use that time now to start building upon that. The only reason I say that is next week we will move to a boundary surface, and on a boundary surface, boundaries are incredibly tricky. And I want to make sure that everybody's up to a particular speed, if you will. Just before I forget, I'm going to quickly take the attendance. So I've now got the attendance. I should point out, somebody told me, well, one of my bosses told me, is if students are still online after the time that they've been allocated to it, and if they're on there for longer than half an hour, they're going to be under suspect of actually not sitting at their PC, which I didn't know that. I don't know if you guys knew that either. So in other words, if anybody just turns the screen on and wanders off, they're going to monitor for that, doing it that way, which no one would do that, would they? It's just something to keep in mind. So I'm just going to stop recording.